Hello there, Algebra students. This is Mr. Kashi speaking. This will be our last video for 10.1. We just have two equations that I want to graph on this coordinate plane over here. And I think what's going to help us the most is if we first kind of we graph what our parent function looks like. And so if you can remember y equals x squared, we're going to have a point at the origin, 1, 1, 2, 4. And then -1 and -2, 4. And I'm just going to kind of draw a dotted parabola like this, okay, just so we can kind of see where we start from. And then we're going to graph these two parabolas here and see how they are different than what that parent function is. Okay, these are called translations. So here the main difference here is that we have this plus c at the end. And what plus c does is it slides. It doesn't change the shape of our parabola at all. It just slides it up or down. What we'll do is we'll take this x squared plus 3, and we'll put that into our table here. And we will be using kind of our standard x values, -2 up to +2. And we'll plug each of these in, get our y terms, and then we'll be plotting it over on the graph. So here we have -2 squared plus 3. So -2 squared is 4, plus 3, that would be 7. And here we're going to plug in a -1. So -1 squared, that would be 1. 1 plus 3, that would be 4. Here we have a 0. 0 squared is 0, but we have to add the 3, so this is going to be a 3. Here we have 1 squared plus 3, so 1 times 1 is just 1 plus 3, that would be 4. And then we have 2 squared plus 3. 2 squared is 4, plus 3 would be 7. So once again, you can kind of see how those are symmetrical around our 0 term. So we'll plot these points over here on the grid. So we have -2, 7. It's right there. -1, 4. And 0, 3. And then this would be 1, 4, and 2, 7. And then you can draw your curve in for the parabola that looks like this. So really, the shape didn't change a whole lot. Actually, it didn't change at all. All we did was we moved our parabola and we went up 3. And that's what this plus 3 means. And so we say that it slid up 3 spaces, not S or 5. Slid up 3 spaces. Okay. It didn't stretch. It didn't shrink. We just took the shape that we had and we slid it up 3 spaces, and that's what that plus 3 behind it means. So next thing that we're going to do is we're going to plot this same this equation on the same grid. So we have x squared minus 2. I'm going to put that in our table over here. Put in our standard x values, and we'll start plugging these in. And -2 squared, that would be 4. 4 minus 2 is 2. -1 squared, well, that would be 1. 1 minus 2, that's a -1. And here we have 0 squared, which is just 0. Minus 2, that's going to be a -2. And hopefully you'll see how these get mirrored down there. So 1 squared is 1 minus 2, that would be -1. And then we have 2 squared, which is 4, minus 2, which is 2. So then what we have to do is we have to come up to the graph and to the grid and plot these points. So we have -2, 2. And we have -1, -1. We have 0, -2. We have 1, -1. And we have 2, 2. Just like that. And our curve would look something like this. Okay, that point is just like that. So really, once again, our shape didn't didn't stretch, it didn't shrink. We just took that same, if you were to think of it as we started at this parent function, you could say that each one of these points moved down 2 spaces. If you take a look at each one of these, they all moved down 2 spaces. So what we say is it slid down 2 spaces from our original parent function of y equals x squared. So if you're to think of that, we always start at y equals x squared, and then we slide it up or we slide it down. The blue graph, we slid up 3 because we have x squared plus 3, and the red graph, we slid down 2 spaces because we have x squared minus 2. So that would be 2 examples of translating the graph up and down the y-axis.